Okay, alright. Hi and welcome back to our educators. So for this video, I'm going to teach you a new subtopic for 1.1 redox, which is displacement reaction of halogen from its halide solution. Okay, so this subtopic, a lot of students say it's very hard, but it is not hard. You should study that in the method that you should study. Okay, so actually for this video I don't do the experiment part first. I'm explaining the concept in two videos. I'll be explaining the concept maybe in two videos, then in the upcoming video only I will be doing the experiment part. Okay, so for this one is just a basic concept only for you to understand for displacement. Okay, so first thing first, before this we already learned about displacement of metal, right, from its salt solution, correct? So today we are going to learn on displacement of halogen. Okay, displacement of halogen from its halide solution. Okay, so this is a crucial subtopic which many of you say harder. Okay, like what I said just now, but it's not hard, it's just you must understand the concept. So first thing first, about displacement. So what I tell you about displacement means throw and combine, meaning that the halogen will throw the previous halide and then it will combine. Okay, something like that lah. Okay, so displacement mostly I will call kick and combine reaction. Okay, this one you cannot write in exam, you know, I just tell for you to understand. Okay, if people ask you, I say kick and combine reaction. So I will tell you how does this kick and combine occurs. Okay, so before I proceed lagi kan, whenever talk about this one, right, you must recall your Form 4 chapter 4, which is you learn about the periodic table. So I think in my channel I already upload for the periodic table video in English version also, full explanation. So if you are free, you can check out the video. I will try to pin out the link in the comment box. Okay, so one thing you must understand, if people say halogen in which group? Halogen in group 17. Okay, and they are non-metal. Yes, you must understand this one. They are non-metal, and an important property is their valence electron. So group 17 halogen have how many valence electron? 7 valence electron. So they have 7 valence electron. So this should be your characteristics. Okay, this is the only characteristics. Okay, have 7 valence electrons. Okay, so this is the first thing that you should understand with halogen. Okay, after that you must understand on the halogen and halide. Okay, so basically halogen, it is a molecules. Okay, but there are a element, but we call them as a molecule because they are same family. Okay, don't ever confuse about element and also atom, you know. Okay, so how I differentiate is, okay, atom means they have a capital letter, one capital letter only. Okay, element means they are from the same family only, they don't have other family members with them. Understand? So let's say I say to you lah, okay, we compare element and compound, right? Okay, I say FeO, this is a compound because they have Fe family and also O family. Okay, let's say I have Cl2. Okay, this is only Cl family, right? Only Cl family, so they are a element but they are molecule. Understand? Just now the FeO, they are compound, so they are atom ke molecule ke ion? They are ion. Kenapa ion? Fe is metal, O is non-metal. You can see in your periodic table. Faham tak? So I say if you want to remember element and compound, you tengok same family ke different family? All same family je ada. Semua chlorine je, semua bromine je, semua is about magnesium only. Let's say everything is about nitrogen only, sodium only, then it is element. Okay, if they have two families, it is compound. I remember like that. If atom means only one capital letter, if molecule means all non-metal, if ion means metal and non-metal. This is how I remember. So halogen, for sure there is they are an element, okay, dia adalah sejenis unsur, okay, but they are molecule. Why they are molecule? Because your famous halogen is F2, Cl2, Br2, and I2. Okay, actually this is the halogen. So in halide form, okay, halide. Okay, when come to halide, they will become, okay, most of you say F2 minus. No, no, no. They will become F minus, Cl minus, Br minus, and I minus. Why only one minus? Because your halogen have 7 valence electron, correct? So, this 7 nak jadi balance, they should have another one only, which is dia akan terima satu electron. So, when dia terima satu electron, that's why the halide have all negative 1 charge. Okay, negative 1 charge indicates that they accept 1 electron on the valence shell. Understand? Okay, that one is the first thing. Okay, then you must know the colors. Okay, so if you learn in halogen, for sure fluorine is a gas lah. Chlorine you learn their color, bromine you learn their color, and also iodine also you learn their color. Correct? Greenish yellow gas for chlorine, bromine reddish brown, and iodine is purplish black. Betul. Okay, so halogen they have color. Wait I write properly sikit. Okay, mas ni. Okay, so halogen they have color. Okay, they have color. Okay, and they have their own state of matter. Yeah, okay, because chlorine will exist as gas only, bromine will exist as liquid only, iodine will exist as solid only. That one is for your form 4. When come to form 5, you must understand that whenever you do electrolytic cell, they will mostly, chlorine will exist as gas for sure, bromine and iodine will exist in liquid form. Okay, they will exist in liquid form. Okay, that one is for redox. Okay, tu satu lah. Then halide, how about your halide? Whatever halide you got in your syllabus, semua halida, they are colorless. Okay, they don't have a color. Don't say white color. Cannot. Wrong. Okay, we won't use white. Okay, white is only to describe solid. Okay, our halides, everything is not a solid. Okay, so whatever people say also, if they say ask the color of halide, colorless. Halide is colorless. Very simple. Okay, so we read the explanation in this part. Okay, the atom of halogen elements has the tendency to receive electrons to form halide ions. Yes, correct, they have the tendency. Why they have the tendency? Because they have 7 valence electron only. To fulfill the complete valence shell, to have a complete valence shell, they must have 8 electrons. That's why they have the tendency. Okay, so they undergoes reduction reaction and act as oxidizing agent. Why reduction reaction and oxidizing agent? Okay, you know that your halogen will receive electron. So oxidation and reduction, which one receive electron? By time you dah master dah. Yes, reduction only receive electron. So if they undergoes reduction process, then what agent? Oxidizing agent. So you must state them. Okay, I do the notes for you, you can copy out. Okay, reduction process. Okay, why reduction process? Because they accept electron. Okay, they accept electron. Normally 1 electron lah. Okay, accept electron. And what agent? Oxidizing agent. So after this, you cannot say your halogens are oxidizing, undergoes oxidation. No, 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 no. Okay, your halogens, only halogens, they would be reduction. Okay, they undergoes reduction lah. Okay, oxidizing agent. This is the main property you must understand. So once you understand this one, these properties you can read by your own. Okay, they say halogens become very difficult to receive electrons, therefore the strength of halogen exhaustion decrease. Okay, meaning that, okay, like this. Okay, your halogens, right, when I'm going down from fluorine to iodine, you know the atomic size is getting bigger. How you know the atomic size is getting bigger? You see the proton number. The proton number is getting bigger and bigger, right? So when the proton number is getting bigger and bigger, the drawing, the atomic structure drawing would be lagi bigger. So lagi bigger, you can imagine this one. Okay, let's say I give an example lah. Okay, for fluorine, ni just wayang-wayang je tau, not correct one. Okay. Okay, let's say you ada yang ini A halogen, ini B halogen, right? So you see your A halogen, the direction, I mean the distance for your nucleus, this middle one is your nucleus, to your valence shell is dekat. So your nucleus dekat, so the attraction force is higher. Okay, attraction force higher. Sorry for my doctor handwriting, dah tulisan doktor dah pula. Okay, then this one, you see the distance of your nucleus to your valence shell. Jauh, betul tak? This one is short, this one is far. So when far, the attraction force is higher or lower? For sure, lower. So when attraction force itu lower, attraction force yang akan attract electrons from the other source. Okay, so this one, you think which one easier to get electron? For sure A lah. Okay, so A may be your fluorine, iodine would be your B. Okay, so that is the concept that I'm trying to say. Halogens become more difficult to receive electron, okay, because when they are going down, the atomic size is getting bigger, right? Okay, so this is the concept that you learn in your form 4. Okay, conversely, it's easier for halide to release their electron and the strength of halide ions as reducing agent. Okay, so halide pula nak halide ni kan, okay, halide they already full, okay, dah full, dia punya valence shell is already complete. So let's say nak jadi halogen balik, they should donate electron, right? So same concept, okay, I draw again like just now. Okay, so now it's your halide, your electrons dah penuh dah. So this one, you see the direction, I mean the distance for your nucleus and valence shell is shorter. So to release the electron, easier ke harder? Harder lah, because when the distance is shorter, it's easier to attract electron sebab force dia kuat. So force dia kuat ini senang tak nak bagi this electron to jump from here? Hard lah, sebab force dia kan kuat. The force kuat yang easier tarik electron. So you think the force kuat now akan let the electron go out ke? No, cannot. But this side, this fella, dah lah very hard to attract electron. Tapi nak lepas tu senang, because the force is tak berapa strong, so dia nak keluar pun sekejap je. Okay, that is the what they're trying to tell with this diagram. Okay, so now you understand why the reactivity is decreasing for group 17, because kita akan see the reactivity on how easy the tendency how easy the tendency of the halogen to attract electron. So among these 4 halogen, siapa paling senang attract electron? Fluorine lah, then chlorine lah, bromine lah, iodine lah, because atomic size kecil, attraction force kuat, senang nak tarik. That is the concept there. Okay, so the displacement of a halogen is carried out by adding a halogen into a solution of another halide. Okay, so this one all, no need to worry much. I will teach you kat example bawah ini. Okay, so let's see this example. Don't see the example first, this one. Okay, this page. Okay, so I already crop out for you. Okay, let me to close the another one tabs. Okay, this one. Okay, so for your understanding level only, just now I say to you, right, about the oxidizing agent, reducing agent and everything, right? Okay, fine. So now, okay, now you must understand one thing, which is you punya concept on this subtopic that you will learn. Okay, so just now I talk about fluorine, chlorine, bromine, iodine and acetamidal. Okay, yang bawah ni is nothing. Okay, but for your redox, we won't focus on these two fellas. Fluorine and AT ni memang tak ada. Okay, there is no reaction, no experiments for your SPM level for fluorine and AT ini. Nothing. Okay, your apa nak kata, you punya concept of this displacement will be around chlorine, bromine and iodine only. Okay, so itu satu. And then you must understand, don't say the strength increases, you understand, oh strength from bawah is very high. No. They're trying to say that the strength is always going daripada paling bawah ke atas tau. So yang paling atas ini kuat. Okay, and for this one, where does the arrow stop? The arrow stops here, right? So this one is paling kuat. That's the thing lah. But one thing you must understand is this arrow is nothing. Okay, as long as you dapat identify your halogen ni what agent, what process, is good. So remember, halogen will always accept electron, so they will undergo reduction. So all of these fellas will undergo reduction. Okay, itu satu lah. Okay, so now I write again, chlorine, bromine, iodine. Okay, this side chloride, bromide, iodide. Okay, so let's say lah, I have a displacement reaction. Okay, wait I write macam ni. Okay, I have a displacement reaction. Okay, so my halogen. Okay, this is my halogen Yang ni kena terang detail sikit. This is my halogen. This one is my halide. Correct? Okay, so you see my halogen. My halogen is Cl2. Correct? Okay, I take my halogen Cl2. Okay, then my halide. Okay, my halide is anything lah. Okay, so between all of these, disebabkan my halogen is chlorine, I cannot choose this chloride as my halide. I have to choose either bromine or iodine lah. Okay, so let's say I choose bromine. Okay, I ambil KBr. Okay, produces what? Okay, before produces what, I want to ask you, this reaction boleh happen ke tak? So how you have to see is, remember, okay, you must write this one. Remember, halogen should be above than halide. Halogen should be above halide. Okay, so from my reaction, Cl2 is my halogen. Betul tak? Sebab dia ada 2 kat bawah ni. So this is my halogen. So my halogen and my halide. Who is my halide? K ke Br? For sure lah Br. Ada student kata K is my halide. Weh, janganlah mencabar my pressure tau. K is a metal. But we are learning about displacement of halogen kan. So the issue is between chlorine and bromine saja. K tu dia akan just duduk and stand je. Okay. So halogen should be above halide. Halogen, ni halogen. This is my halogen. And my halide is down here. So when my halogen is above my halide, then displacement can occur. Okay. So you can write, thus, displacement can occur. Okay. Can occur. Dapat tak? So, because my chlorine is higher, so the chlorine will go here, will kick this Br. Chlorine only have rights to kick his family member. Who his family member? All this halogen is dia punya family member lah. Okay. Chlorine, bromine, iodine. Tak kisahlah in what phase dia boleh kick. Okay. You can say me, oh cikgu kat sini, ini chlorine, this one is bromide. Can it kick? Yes, can awak, because still they're same family only. Okay, so my chlorine can kick my bromine, right? So now what will happen? Come back to my definition. What I say my definition? Kick and combine. So can kick. So because this chlorine kick my bromine, so he can combine with the K right now. So K, he kick my bromine now. So KCl. Should I put the 2? No. Why? Because sekarang my chlorine from this halogen when gabung dengan benda lain dia jadi halide. Halide dia punya charge is -1. So K is K plus, Cl is Cl minus. Dia silang, nothing. Okay, because 1 tak perlu tulis. Then what happened to the Br that I kick? Saya kick dia daripada halide, right? So dia jadi halogen back. Br2. This is the reaction. Understand? This is one example. Example lah. Okay, example 1 for you. Okay, I give you another one example. Okay, let's say lah, I give another 2 or 3 lah. Okay, I use black color pen. Okay, example 2 for you. Okay, let's say I have bromine. Okay, I have bromine plus with bromine. Okay, I put chloride lah. Okay, I put chloride. So I have KCl. I don't know lah, I memang suka guna KCl. Okay, produces what? Okay, ini example 2 you. Okay, example 3 this side. Example 3, I have Cl2 and then I have Ki. Okay, tak apa, disebabkan it will look a bit mischievous. Okay, saya bawa kat sini. Okay, so first one ini, you rasa reaction boleh happen ke cannot? Okay, the issue is between whom and whom? Bromine dan juga Cl lah. Sebab this is about halogen and halide, correct? So this is my halogen. How I know? Dia ada 2 kat bawah. So this is my halogen. And Cl is group 17. Nothing. Combined with another one filler. So this is my halide. So my bromine is above my Cl or no? Okay, this is my bromine. My Cl is kat sini. Cuba tengok, bromine kat sini, Cl kat sini. Halogen should be above halide, thus displacement can occur. Now my halogen is below my halide, yes or no? So you think can occur or cannot? Cannot occur, yes, correct. So no reaction. Done lah. That's the answer, that's the only answer. Okay, just very simple concept. Okay, then Cl2 plus Ki. Okay, so you see Cl2 and Ki. Okay, so your Cl2 kat mana? Okay, Cl2 is in the top. Ki, which is my iodide kat sini, I. Halogen should be above halide. Halogen above, halide below. So displacement can occur. Yes, can occur. So this fellow will travel from here. He will kick my I. So dia akan jadi KCl plus I2. Done lah. But remember that you haven't balanced out your chemical equation. Ni pun you tak balance just now. Okay, so pastikan you balancekan lah the equation. Okay, so let me to balance out the equation for you. Okay, so my Cl I got 2 here, I got 1 only here, so I put 2 here. My Br got 2 here, so I must add the 2 lah kat sini. Okay, same juga. This one no reaction, so no equation. Yang ini pun sama juga. Cl I have 2, right? So I have 2 kat sini, I have 2 kat sini. So done. So first thing first, you must understand the concept of displacement. So I already give you 3 examples, right? Okay, so tak apa, I give you exercise for this video. Okay, which I will give around 3 to 5 questions. I want you pula untuk bagi tahu whether the displacement happens or no. If happens, write the complete chemical equation. Okay, so let me to write the question. Okay, so I already give you 5 questions. So you determine for me the reaction can happen or no, and write chemical equation if occurs lah. Okay, equation if happens. If happens. Okay, so this is the complete answer lah for your exercise questions. So I already record a complete lengthy video for you to explain about the color and everything. So by now you tahu lah the color and everything. Okay, but whatever color that I tell to you is all for the periodic table that we belajar in our previous knowledge. For now we will have some changes. Okay, we will have some changes after this. Okay, so that one we will see in the experiment part. Alright, because when doing experiment we won't use what you call that, bromine and iodine lah mostly. We won't use solid one, we will use liquid iodine. Okay, we will see in this experiment, but just I show to you lah. Okay, this one. Okay, so you can see we will use trichloroethene and so on. Okay, even this one also you can use this this diagram also you can use. Okay, to see whether the reaction happen or no. Try to do lah. Okay, potassium chloride and bromine water. Okay, you think the reaction can happen or cannot? Potassium chloride and iodine can happen or cannot? You can try to do. I will discuss about this also in next video. Okay, that's it from me for this video. Meet you in another one video. Thank you and bye.